Hi everyone, this is group 16. I'm Eric.
I'm Robbie.
And Paul and Stephen, they happen to not be able to come, so they write the script for us. Pretty nice. Alright. Actually, we have already done all 4 of our project, and this will be our awesome makeup project. So, Robbie and I will be talking about big O notation, also big omega notation. And I will introduce Robbie to talk about the big O notation.
Hello, everybody. I'm here to discuss big O notation with you. Now, there are 2 functions in big O notation. There's f and g. And the way we say it is that we let f and g be functions from a set of integers, or the set of real numbers, to the set of real numbers. We say that f of x is big O of g of x if there are constants c and k such that f of x is less than or equal to c times g of x whenever x is greater than k. Basically, intuitively, the definition is that f of x of big O of g of x says that f of x grows slower than some fixed multiple of g of x as x grows without bound. Now, an example of this is the function f of x, x squared plus 2x plus 1, is big O of x squared. And we can prove this when x is greater than 1 and 1 is k, and x squared is greater than 1. We say that 0 is less than or equal to x squared plus 2x plus 1, which is less than or equal to x squared plus 2x squared plus x squared, which is less than or equal to 4x. Basically, in this situation, to make the statement true, we have c is equal to 4 and k is equal to 1. So, in this, f of x is f of x is f of x is less than or equal to 4 times g of x, or x squared plus 2x plus 1 is less than or equal to 4x squared when x is greater than 1. Now on to Eric to discuss big omega notation.
Cool. Now, I hope everyone knows what big O notation is now. So, now I'm going to talk about big omega notation. They're actually very similar. So, what is big omega notation? Let's say f of x is big omega of g of x. What does that mean? Well, that means the absolute value of f of x is greater than or equal to the absolute value of g of x times a constant c when x is greater than k. So, intuitively, we can say that f of x is big omega of g of x, meaning that f of x grows faster than g of x. G of x with some multiple when you have x going to infinity. Oh, note that x has to be greater than k. Okay, now let's go on to the example. Pardon me. Okay, so this is actually from a homework problem. So first, f of x is equal to log x with 10 as base, and f of x is big omega of log 2x. So what I'm saying here is that when x is greater than 1, log x with 10 as basis is greater than 0. Let's take a small example. So what if x is smaller than 1. Log 10, let's say 1 over 5, will equal to log 10, 5, negative 1. I hope we all know this conversion because it's actually high school. Well, anyways, this will lead you to 5, and it's a negative number. So this is just a small demonstration that we need x is greater than 1 so that we have log 10x that is greater than 0. Okay, now go on back to our function. So our function say like f of x is equal to log 10x, which is equal to log x over log 10. Well, in this case, actually, the representation is the same as having 10 as basis, but we omit it because of convention. The reason that I need to write it this way is because it will be very useful later on. So now log 10x over log 10 is equal to log 2 over log 10 times log x over log 2. Again, remember a log is intuitively having a 10 as basis, but we don't write it normally because it is convention. So in this case, we will have log x over log 2 times log 2 times over log 10. And that is greater than 1 times log x over log 2. Why is that? Let's take out the difference between these two functions. So 1 times log x over log 2 and log 2 over log 10 times log x over log 2. So the only difference is these two. And then I say this one is greater. Why? Because log 2 over log 10, which is just log 2, is actually equal to around 1.414, which is greater than 1. So in this case, since we have log 2 greater than 1, and we have log x and log x over log 2 the same, and they are all positive, so this equation holds. Okay, so I have the greater than equal to over here, and this will just simply equal to log 2x. So in solving problems and finding the big omega notation, it is very important to find two key factors, which are mentioned in the previous slides. First is the constant c. Second is the constant k. They are so-called the witness. And so where's our c and k? So let's find our k. X is greater than 1. So basically, 1 is our k. And what is c for the big omega notation? Well, it's actually just 1 because 1 works. Now, because we find c equals 1 and k equals 1, we got two witnesses. That concludes that f of x is the big omega of g of x. Well, I hope that our explanation is clear enough that you guys will understand what big O notation and big omega notations are. In the future, if you have time, you should look into big theta notation.
For more discrete mathematics videos, visit knowatom.com. That's knoatom.com.
I hope you enjoy. Thank you.